Right, so hello everybody. Who was here for the Flutter talk earlier? Yay, we're here to fix that. Okay, so we were talking about tribes. So Rich was talking about Flutter being one tribe. Well, we belong to Compose, so we're a different tribe. Okay, so they are House Atreides, we are House Harkonnen. Okay, so I would like to introduce you to Fade. Yeah, and for the rest of this session, I will be Beast Raban. Okay, so we are here to talk about one of the alternatives to Flutter. So we're talking about Compose. So my name is Garth Gilmour. I'm the head of learning, aka chief trainer, aka person who begs clients for money at a company called Instil in Belfast. So Instil is 80% a software development company and 20% a professional services company. We do all the consulting and coaching and mentoring, and you know all that kind of thing. But that's not why you're here. So what are we here to talk about? Well, we're here to talk about Compose. Who has heard of Jetpack Compose for Android and as a way of creating UIs and so on? Good, it's not that, okay? Disregard anything he's about to say, it's not that at all. So Compose isn't an Android thing. It's not just a GUI thing either, yeah? And if you use the JVM, it's of interest. So who here uses the JVM programs in Java or Scala or Kotlin or Clojure or anything like that? Even if you don't, it's still of interest, as I shall attempt to prove as we go along. So basically, I'm going to do a third of the session and just introduce you to Compose. And then Kelvin is going to come up and show you some of the wonderful things that we're currently doing with Compose and Android. So here's my demo. And you were probably expecting an Android demo. It should be very obvious this isn't an Android demo. So we've got a console line application. And as we type a number, we print the height of the pyramid, and the pyramid gets drawn for us. Okay, so what's going on behind the scenes there? Well, here's some Kotlin code, standard Kotlin code to print a pyramid. Who knows Kotlin? Quick show of hands. Excellent. For everybody else, we offer a wonderful range of brilliant courses taught by friendly and highly skilled instructors. Operators are standing by. Okay, so if you know Kotlin, this is how you print a pyramid. If you don't worry about it. This is what we want to get into here. So this is our user interface. So at the top, we've got a variable, and that variable is being created indirectly. Whenever you say buy, magic happens in Kotlin. Okay, so this is going to be some state that's going to be managed by the user interface. So whenever that state changes, the UI can react to it and redraw the user interface. So our user interface here is represented using a DSL. So you see we've got columns and text blocks and all that kind of thing. And then finally, we've got the code to read a value from the console. So we're going to read a value from the console, use that to calculate the height, and change the height variable. And whenever we change the height variable, that alters the state of the GUI, and it's going to get re-rendered. So this is all being done by Mosaic. Mosaic is an implementation of Compose that runs on the command line. Okay, very, very interesting. So started off with that just to show you that Compose doesn't have to be an Android thing or a GUI thing. It's useful in all kinds of places. However, the UI that we just did, it was just one single DSL block, and obviously that's not maintainable. So what we would do instead is we would create composable functions. So a composable function is just any function annotated with composable. You know, there you go. And inside there, you can do GUI stuff. You know, you can declare your widgets and nest your widgets and whatever you want. And composable functions invoke other composable functions in order to build up the complete user interface. So clearly magic is going on there. So you use composable functions just like normal, but then a compiler plugin attaches to the Kotlin compiler and goes and does the magic for you. Okay, so it's a little like suspending functions in Kotlin. In Kotlin, whenever you declare a function suspending, magic occurs behind the scenes, done by the compiler, and you get a function which can be paused and resumed. So this is a very different use of annotations as opposed to, for those of you who've done Java, you may have seen JUnit, Spring, Java Persistence API, and so on. And in those scenarios, we annotate some code, and that annotation is discovered at runtime using the reflection API, and the framework reacts appropriately. That's not what's going on here. So what's going on here is there's a compiler plugin that sees the composable annotation at compile time, obviously, and does something with it. So a good way of thinking of it, as proposed by this very famous article back in 2015, is that functions have different colors, okay? So think of a regular function maybe as being blue, and a suspending function as being green, and a composable function as being purple, and so on. So this is a different color of function in our application. So at the end of the day, what is Compose? Yeah, so Compose is a library designed to efficiently build and maintain tree-like data structures. So you can use Compose to build and maintain any tree-like data structure. It doesn't have to be a user interface, okay? So for example, if you were trying to create a refactoring plugin for your IDE, well, what are you working with? You're working with an abstract syntax tree. You know, that's what a refactoring does. It takes the syntax tree generated by the compiler, moves things around a bit, regenerates the code, you know. So if it's a tree-like structure, you can generate it from Compose. And then the idea is that you're going to have state, and every time that state changes, we need to regenerate parts of the tree, and we want to do that as efficiently as possible so that the tree changes over time. Okay, so this is a very famous definition of Compose. So if you think that Compose is just about UIs, you fool, you know, you've fallen victim to one of the classic blunders. The most famous is never start a land war in Asia. You know, the second most famous is that Compose is about managing trees. All UIs are trees of components, therefore Compose is all about UIs. You know, it's not, it's much more applicable than that. So you do have Compose for user interfaces, and as we'll mention in a minute, there are many different variations of that, but underneath that, there's the runtime and the compiler, and that's universal. You know, you can use that for any kind of tree-like data. And Kotlin is now multi-platform, so Kotlin, as well as compiling to bytecode, you can of course do it in Android. There's also a JavaScript, you know, a 2JS compiler, and there's a native compiler as well. So everything that we're going to be talking about here can be used in a multi-platform environment, and that's an entire afternoon's discussion in itself. So there is Jetpack Compose, and that's the UI language that you use in Android. And I don't need to talk about that because Kelvin's going to go into it in a lot of detail. But there's also Compose multi-platform, and that gives you a way of using Compose for desktop applications or also web applications as well. Okay, so anybody have to do Java Swing at college or anything, the Java GUI library? Yeah, terrible, isn't it? Yeah. And then there's the successor Java FX, which was introduced just as web apps were becoming really popular, and therefore didn't stand a chance, unfortunately. You know, so there's a kind of hole for anybody who wants to do JVM coding on the desktop. You know, what GUI library are you going to use? But this fills a hole. And then you've got things like Mosaic, you know, for the command line. That was our original demo. And then it starts getting interesting. So here is an example of using Compose, but we're using it to generate a flow. Okay, so a flow is the Kotlin coroutines version of a flux, an observable, a reactive stream, you know, something like that. Yeah. So what we're doing here is we've got our Compose code, yeah, and inside there we've got procedural code, and that ends up generating a reactive stream. So anybody done reactive programming, and anybody used lots of nested flat maps and all that kind of stuff? You know, so this is designed to be a much simpler alternative to that. Okay, so some interim conclusions. So yes, Compose is a declarative library for user interfaces. Yes, it's now the default UI toolkit for Android apps, but it's also an emerging multi-platform library for any kind of user interface. And even more so, a general way to manage tree-based data, and a nice shortcut if you're interested in coroutines and flows, which is how concurrency is done in the Kotlin language. So let's just peek under the hood a little bit. I do have an example here, which is a simple single-digit calculator done using Compose running on the desktop. Usually like to show it live, but we don't have time in this scenario, so you'll have to take it from me that it does actually work. So here's the shell. You know, we've got an application with the window. Here's some of the composable functions, and you can see here whenever we say remember, we're setting up some mutable state, and every time that mutable state changes, the important bits of the UI will get re-rendered. And then we've got some event handlers, and those event handlers are going to change that mutable state. And then we've got a composable function. So we've got a composable function here for a number button, which is just a button with some text inside it. So nothing complicated there. Let's decompile it, okay? So if you run this through the Kotlin decompiler, you'll see that the compose plugin added 2 extra parameters, okay? So every time you declare in Kotlin a function as being composable, what happens? Yeah, well, a compiler plugin comes along and adds 2 extra parameters. One of these is a composer object, and the other parameter is an integer, okay? So what's the first parameter for? Well, composable functions emit nodes. That's what we've been saying. They build a tree. Okay, so whenever you call a composable function, it's going to produce 1 or more nodes that get added into the tree that's being built or possibly rebuilt. So that's what the composer object is for. So the composer object contains methods to emit nodes, which will get added to the tree. Okay, and then it also adds this integer. The integer represents a relative key. You know, it uniquely identifies each node. In other words, let's say we've got our calculator. So we're going to need many number buttons, okay? So we'll need, you know, number buttons from 1 to 9. So each of those is going to be generated by a call to this function, but each of them is different. You know, each of them will hold a different number. You could push a different one. You might want to make them different colors and so on. So we're going to have many number button widgets. We need each number button widget to be unique, because technically, you know, if we only changed one of those buttons, that might be the only one that needed to be re-rendered. So that's the purpose of the integer. The integer is adding a key that identifies each node. And the ability to do that is what they refer to as positional memoization. Scary word. Yeah. So underneath the hood, they have this data structure called a gap buffer or slot table. And what they do is they take the tree of nodes, which is obviously hierarchical, and they flatten it into an array for performance reasons. Okay. So you have a sequence of groups, and groups can be declared inside other groups. And it's this ability to nest groups within other groups that enables them to recreate the hierarchy, to recreate the tree. And this is all obviously all being performance tuned and optimized to bits and so on. But it is pluggable. You know, if you didn't want to use this data structure, if you wanted to use something else, well, then there's the ability in the library to do that. Right, so where are we? You know, what have we learned? Yeah, well, we've learned there's this thing called compose, yeah, and you use it to declare composable functions, and composable functions emit nodes, and those nodes are trees, yeah, and that tree can be a user interface, and that's what goes on in Android. And this does address a crucial need, because before there was compose, you did all your UI development with XML, and that was terrible. Okay, everybody hated the XML. Even me, the world's biggest XML fan, wasn't a fan of it in that particular use case. Yeah, it also fixes an outstanding pain point on the desktop, because Java GUI libraries have been embarrassing for a while. Okay, Swing was good in its day. That day was decades ago. You know, Java FX never got a fair chance to kick off, and so on. So this hopefully fills that hole. You can also use it in the browser, you know, using the Kotlin JS compiler and environment. Will it kick off there? That remains to be seen. It continues the trend of multi-platform Kotlin. You know, Kotlin being a language that's no longer just for the JM or just for Android. You can use it just about everywhere these days. And most importantly, you can share the code base, you know, so you can write some Kotlin code, some business logic, some entity classes, and then use them in any of those environments. And it's something to keep your eye on. So a lot more innovation can be inspected in this particular area. So if you're interested, here's an in-depth talk from KotlinConf, an in-depth white paper that goes into it in lots of detail. A very good podcast episode from the Talking Kotlin podcast, and a book on the internals of Jetpack Compose for the really, really gory details. Yeah. So those are a bunch of resources you can get into. So this completes our high-level introduction. Before Kelvin gets up and, you know, drills down and shows how we're actually using this in production, are there any initial questions? Yes.
So you mentioned about it's overcome the weaknesses of Vue in Android or XML. to make it more similar to Flutter. Actually, it's very similar to Flutter. We have the widgets, we have nested widgets, and the tree is really similar. So it's also cross-platform. So what is the advantage? Why should I use that?
Well, because I don't use Flutter, but I believe Flutter uses Dart. Yes. So with Kotlin, you can use Kotlin for just about anywhere. You can use the JVM and any JVM libraries, you know. So if I want to use the JPA for persistence, if I want to use Spring Boot for microservices, if I want to do cloud deployment, if I want to write an Android app, you know, anywhere where Java, the JVM can be used, Kotlin can be used, you know. So it just opens up all of that as well to you, you know, whereas with Flutter, as I understand it, you know, it's based around Dart, which is still, although I've played with Dart and I like it, you know, but it's still it's a niche environment, you know, it's still a minority environment, whereas with Kotlin, everything is built on top of the Java virtual machine and the 25-year history, you know, that you've got there, and all the different libraries and frameworks and so on. So you can just plug into that directly. Yeah. Yes, because you whenever you're designing your application and your architecture, it's always going to be a mix of the old and the new, you know. So they by building it on top of Kotlin, you can have all of the old stuff that you have to use, all the new shiny stuff that you want to use, and so on. So it's all there and available to you, you know. Yeah. Cool. I think I'll hand over to Kelvin then.
Thank you, Garth.
Sorry, fade.
Okay, folks, part 2. My name is Kelvin Harron. I'm a senior software engineer at Instil, and I'm on the dev side as Garth is on the training side. And while Garth said Compose is not just an Android thing, it's just not a UI thing, I'm going to talk about Jetpack Compose, which is the Android UI thing. But to do that, I'm going to give you a short history tour of what Android UI development has typically been like with XML. I'm going to give you some examples of using Jetpack Compose in a few apps. I'm going to have a little bit of a focus on navigation and accessibility, and I'm going to give you a sneak peek at something we recently released as an app in the Play Store. So traditionally, you would do your user interfaces in Android with XML. It looks like this. You mark up your views like this, and you provide an ID. That allows you to find that ID in your activities, be they defined in Java or Kotlin, and then you can get that text view, and you can start applying your text, changing your colors and such. At a high level, what we're doing is we're gluing our UI and our state together, which is a fundamental problem that Android UI development has always had, because you constantly have to re-glue these things, keeping your state up to date. But as developers, we also have the challenge of keeping our XML and our activities, fragments, views, however they're defined in Java or Kotlin, together. So that's a real challenge for us. 4 years ago, I joined Instil, and I learned about Kotlin, and I learned about data binding. And that allows you in Android to still use XML. But the difference now is that we actually have a layout element at our root, and we're able to find these variables. So we can put variables into our XML, and that allows us to bind those fields to our actual views. We still have to glue our code together with Java or Kotlin, and we still have to set our fields like this. And then you have a view model. Whenever that text updates, I don't have to go and reglue that, and I can do some other sort of magic in there as well. If that seems really long-winded, I'm just trying to make a point. It's reorientating the state to the UI to better represent our state, but there's still a lot of gluing going on there. And more recently, we have this shiny new thing called Jetpack Compose, the modern UI declarative toolkit for Android that promises to do this. It promises to let our UI represent our state, so we don't have this problem of trying to glue these things together. But for me, somebody that's worked in Android for about 5 years, I have to throw out all this old knowledge that I've gained because it's radically different. So let's take a look at what that's been like. So working with Compose, first of all, I want to introduce an iOS app that our graduates and interns back in 2020 developed. Whenever a new group of engineers join us, we like to give them a more meaningful project than just a little bit of a to-do app, guide them through working with design and product folks to give them a bit of an idea about what actually working with our clients will be actually like. Back then, we wanted to build an iOS and an Android app. Back then, Compose hadn't actually released at 1.0. I did check it out. I thought it was quite cool, but very different. The problem was the tooling was really bad. the documentation was really out of date. And God help you if you want to go in Stack Overflow, because you're flying blind basically. So I recommended that we don't actually give them that opportunity to build an Android app. It's going to be a really bad experience for them for the first couple of weeks. But what if we could take this app that we've developed in-house, and what if we made it with Jetpack Compose like this? What would that look like? Probably something like this. So the last few months, I've actually been working to take that app and build it in Jetpack Compose. This is all Android code, this is all Jetpack Compose. So I want to take you through what that's been like. First thing is sharing components is really easy. You're really encouraged to do that. And that just keeps your classes nice and short. But also, if anybody's worked in XML before, you'll know that previews are really bad. Here, previews actually work. I have full confidence that what I see in the preview is what you're going to see on a device. So very quickly, I can see what dark and light mode is going to look, which for developer experience is a huge benefit. And something like this estimate card. So I don't like redefining view components throughout the code base where they're needed in specific areas. This one card is defined. It's a material component provided by the library. And we have this default modifier that's passed through. So anybody that wants to use this card, like in the podium, they can actually provide a different width and height, because we want a smaller one there, but I don't want a bespoke one with different business logic provided. So that allows us to pass that through. And because it's Kotlin, we're able to use one of my favorite things, which is a when statement. All the card selections that you can make for this app is a sealed class. So we're able to go through and reuse this logic for what we're going to return whenever a card is passed through, which is really nice. And then just a little bit about flows. So flows are an asynchronous stream of data in Android or in Kotlin, and we can use it in Android. So whenever we're working with Jetpack Data Store or Firebase, that's going to be it's going to be IO, it's going to be network. We're not guaranteed that at the time, and we block the UI thread. We must protect the UI thread. So what we'll do is use a flow, a promise that we'll get these asynchronous stream of data back. So that lets us propagate that down to the view model. He's calling those classes, getting a state flow, which is essentially a flow that something like the view can observe, getting the current and any new data that comes in. A little bit more detail. We can see here that we have this player service in the estimate app. There's a callback flow. Whenever Firebase has a whole new list of players that join the lobby, we're going to send a list of players back. And then in the view model itself, we're using this state flow. So it's going to reach out and get those players. And once those come in, it's going to be able to propagate that to the view itself. And we're using the view model scope. So that means whenever we navigate away, we'll clear up those resources. We're not going to start hogging performance, which is really nice. And then again, there's that magic by keyword. So we're just getting a list of a data class, or just a list of players whenever you come to your compose code. That just means that you can use it in a lazy column like this. If anybody's ever used a recycler view in Android, you'll know how nice this is. This is how you just have a simple list of views coming down. We're able to pass those players in, and this gives you a really nice preview of what you're looking like. That's the data class, basically, that was defined. So that's really nice to work with. Another app I want to talk about, which is actually one of our client applications, who kindly let me talk about today, is the Viper app. Viper is a product intelligence platform. Their unique selling point is for supermarkets, for businesses in food and drink. If they want to make changes to a product, or they want to maybe launch a new product, but they're not quite confident because it's a lot of money you need to spend on that. It's a lot of time before you can actually find out if consumers would actually buy it. So anybody like us, we can download the app, we can answer some questions, and that'll define us in a demographic that you're in this certain group, you have these certain shopping habits, and then businesses can target you and ask you questions about these products before they actually even have to think about going to market with them. And we're working with Viper more recently to help improve their software solutions, and that's an Android app and an iOS app. But a little bit more about the Android app itself. So it was originally started back in 2016, and most of the UI code is from them as well. That means there's a lot of the model view presenter pattern throughout, so a lot of interfaces. And since we started working on it in this year, we have shipped 2 whole new features that are driven with the UI with Jetpack Compose. And we've also rewritten 2 of the existing screens with Jetpack Compose as well. So whenever you take ownership of an app, and it maybe hasn't gotten a lot of love in a while, you start seeing that your dependencies are out of date, and there's all these things like, oh, we should change this, we should bump these dependencies. And because it's an old app and there's not really that much test coverage, what starts to happen is you try to introduce a little bug here or there, and you go out and you try and find the cause, And you know what? Then you start to find a whole heap of problems. And I'll give you a very clear example of this. In the Viper app itself, whenever you log in, you have a list of the steers. There are questions that companies are asking you. And whenever you navigate away, you can look at your points, because if you answer enough questions, you can get a bit of money, which is nice. I bumped just the Kotlin version in the app, and this behavior would happen. I don't know why this screen wouldn't appear again. And I'm embarrassed to admit how long, I'd be embarrassed to admit how long I spent trying to figure it out. So what I decided to do was, let's just rewrite it in Compose. This is a fragment, and it was using XML. But instead, what I decided to do is whenever we're calling the onCreate view, we're going to return a compose view itself that's going to give us access to a composable scope, so we can start calling our composable functions. The problem with this, though, with rewriting old stuff is you find some really old stuff, some really kind of scary stuff. There was this aspect ratio image view. There was over 200 lines of really old Java code. It's really scary. I don't want to figure out what's going on in here, and I certainly don't want to change it. So with the Android view composable, I can just pick up what was there and drop it into Compose, and it's going to behave and look as it did previously, which is really nice. But we all love a good rewrite, and that's what I decided to do. So I took those 200 plus lines of code in Java into 87 lines of code in Kotlin, and it looks really nice. And the best thing is, you can't really tell a difference. So I think we're doing something right here. And in this example, folks, for anybody, again, that's worked with the cycler view and the adapter, you have all of these different classes that you need to work with to try and produce a list of views that are efficiently rendered on the screen. So we're able to remove all of that. And because we're using Compose with a lifecycle aware view model, that's going to enable a nice testable implementation. We start bringing some unit tests in there, so we start to get a little bit of confidence about what we're now maintaining. And most importantly, we fixed the bug that we introduced because we bumped the Kotlin version, which is great. And these are just some other examples of changes we've made recently, where here's a screen, let's make some UI changes just to make it a bit more lively. Why don't we just rewrite all that in Compose as well? Every single time that we've done this, we've been able to reduce the complexity and add more features, add a little bit, make it a little bit more dynamic as we're going through and improving the app. So we have less stuff to maintain, there's less code there, and we feel pretty good about it because we've taken ownership and added some testability as well, which has been really nice. Now, navigation is a very contentious topic in Compose. I'll get into it. Before that, though, a little bit of a history lesson. Previously, you would navigate from activities, which is bad because that transition is quite heavy. It's quite demanding in your performance. And based on the brand, the animation can be a little bit different. So that's not great. So we decided to start using fragments. And a lot of people didn't like the API for a very long time, but it's a little better nowadays. It's better documented, at least. Most apps today want to get to this point where there's a single activity architecture. Whenever you launch the app, you have all your fragments you navigate through, so you don't have to worry about that transition. With Compose, you can keep those fragments, like I showed before in that example, or you can just use all of composable screens, which we've done recently in the Viper app. And Estimate, the poker planning app I showed first, that's an example of just all composables. So with navigation in Compose, with the official library, you have this nav host, you have this nav control that you're passing down. And if I have to say 2 screens, and I want to go from the profiles at friends list, I'm going to pass the string name of the friends list because that's the route that we're going to. And I can pass arguments as well, and I can call that argument with the string name, and feels kind of icky. And this is a contentious point for a lot of people using this library. The first time that we developed the UI feature, we had about 6, 7 screens, and we looked at that navigation bit. It felt a bit like this. We didn't really know what was going on, and we thought that maybe we're doing something wrong, but this isn't very good. So how about we go out and find something a little bit better, a third-party library that could resolve this for us. So the intern in our team, Benjamin, actually found this library called Compose Destinations. It's the first KSP library that we've used. It uses the official navigation under the hood, but it hides that complexity, it hides that boilerplate, and most importantly, it gives us that type safety that we've been missing before. And all you have to do is annotate your composable with a destination there at the top, which is great. And because that then allows you to the library to generate this for you in a nav host, and you get this destinations navigator that you can use to basically do your navigation with. And because it's generated for you, you get this nav graph, As you saw there, this was the labeled start position, and all these routes at the bottom are in the Estimate app. These have all been annotated somewhere that you can navigate to. And then you get type safety, because it's all generated for you, which is really nice. And passing arguments as well, like in the Estimate app, is as simple as this. Although I did have to make a serializer, it's provided from the library, which is really cool. One thing I would say with Jetpack navigation more recently, they have given examples that if you're supporting a wide range of devices, like big tablets or desktops, maybe you want to use different components. So that's probably something you should consider if you're building for many screen devices. But we're not at the moment. We're keeping things quite simple, and it's working really good for us. Now, accessibility. Accessibility, a lot of people might think, isn't that just our parents and our aunties and uncles, whenever they get their phone and they turn the text size up and things start to go off the screen and it kind of breaks the layout? You know, something like this, what happens when the text gets a little bit bigger? Well, mobile accessibility is about making apps and websites more accessible to folks with disabilities whenever they're using any devices like mobile phones or such. In Android, there is this feature called TalkBack, which is whenever you interact with the UI, it's going to act as a screen reader. It's going to describe to the user whenever you touch somewhere what this actually is and what you can actually do with it. If you are interested or you're working in Android, I recommend you download this tool from the Play Store. It's called Accessibility Scanner. You run this overlay and you just walk through your application, and it's going to start to find all these issues for you. So in Estimate, it recommends the contrast here, the sort of green and the white is not too good. But if you don't have accessibility identifiers, descriptions of what these buttons are, it's going to find that for you, because folks with screen readers, the screen reader is not going to be able to help them. So your app becomes a little bit useless to them. If you don't do that and you launch in the Play Store, Google is going to do all that testing for you. And it actually found an example. This app, the Viper app, it's supported in the UK, Germany, and France. That's why it's in German here. And I find this problem that this dialogue might not be readable by screen readers. And sure enough, I launched it, and somebody with, say, a visual impairment is going to launch the app, and they're going to find that, yeah, I don't know what I'm looking at here. Is it a dialogue or is it something else? So what we can do is use Compose's semantics modifier. And what we're saying is anything that's a child in the alert dialogue, all the text and the layout and the buttons in there, we can annotate it with an accessibility label. So we can describe to the users who are visually impaired, for example, whenever they're using TalkBack, it's going to highlight the whole dialogue, so we can give them the confidence to know that this is actually something pretty important, rather than just relying on, oh, the text is red, so that might be an important thing. This improves the user experience for those folks. Android's quite unique in that we have lower-end devices with smaller screens. We have the latest flagships with really tall, really nice, crisp displays. And then whatever crazy thing that Samsung comes out with, like the foldables. So it's a bit of a challenge for us folks on the UI side. So whenever you're working with UI mockups, it's your job as an engineer to understand what Jetpack Compose can do, what's the default behavior, and what's things that you can do to work towards supporting these devices. I personally work on a Motorola G from 2018. It's really slow. It's got a really small screen. And it's easier to build up from a smaller screen than build for like a fold and then try and squash that down. But as part of that process, you need to factor the time in that if you're given these designs for, say, that it's Pixel, what about making it accessible on smaller devices? So testing and actually building for that. That's something as an engineer and as your team, you need to factor that into your estimations whenever you're doing your sprint planning. And you need to agree on copy for accessibility labeling. So maybe saying that this is the account deletion dialogue, maybe you want to have a think about a little bit more than that. So work with your designers and your product owners and make them aware of these things so you can ultimately ship a better user experience. Okay. So you're sitting here now and you're thinking, Garth and Kelvin have sold me in Jetpack Compose. And I don't even work in Android, you're thinking, but I'm going to make my team use this because this is great. This is an amazing thing. Or maybe I do work in Android and I'm just going to slip it into the next couple of PRs and they're going to think, you know what? You're great. You've made our app so much better and we're so modern and everything's just great. If you do this, it'll probably look something like this. You'll have all these bug tickets, all these things that you didn't understand because you didn't take a phased approach. Your team members are going to be shouting at you, being like, what's the difference between a box and a column? I don't know, explain these things to me, and you're gonna stumble there quite a little bit. So what I recommend instead is this phased approach. We didn't take this approach. I wish we did, but you learn. So this is a rhetorical question. Of course you do. Of course you've got some custom UI going on. So why don't you try, if it's in XML, if it's programmatically in Kotlin, why don't you redo it in Compose and maybe make a gallery app of all your custom components? Estimate that I talked about and I've silently launched this week in the Play Store. I don't care if nobody downloads it. I don't care. We have a resource internally now that if somebody wants to learn Android development or wants to improve their Compose skills, we have that resource internally, which is incredibly valuable, because trying to make those changes to our client's application, you have to go through QA. There's other concerns for the business. It's not the right place to do that, but internally, that's the best place to do it, because you're going to provide this foundation to educate your team. And ultimately, you're going to define some really good standards and best practices. That's going to make it a really consistent developer experience for everybody. So to conclude, anything we do in Android now, we're going to use Jetpack Compose. There's no question about it. To start with, it was a little bit of a stumble for us, but we're pretty happy with it now because the documentation is really good. There's a lot of really nice resources, especially from Google with their code labs, that will definitely keep you right, and a lot of community content as well. I showed that how good the tooling is and some really nice examples of some third-party libraries that have made it easier for us so we can develop faster and better. And it was not easy to start with. At some points, we were thinking, should we just go back to XML because this isn't really good? This is probably slowing us down a little bit. But I would say now at this point, it was more than worth, well, it was worth stumbling for. Any questions?
So you change all the structure in the coding basically to view model to do compose. When you are doing it, you became a tree and I don't say widgets, components in it. What about the state management? Is it different from the view model or the data injections and anything when you compare with the compose, or it just goes with it?
With the Viper application, the model view presenter approach, I don't think the state management was very good there. It was quite dumb, maybe kind of leaky. And because of the example that we set up with the flows, for example, we find that whenever you navigate away from the screen and that screen is no longer being used, that view model that's tied there, its onClear is going to be called. So at that point, all the flows that are pumping data through, they're going to be all cleaned up as well. So we find the state management pretty good for that.
I don't know Android much, so my question is not about development of application, but about Viper. Am I right? People can get money for answering questions. We cheated, right? And we created bots and tried to get money not answering honestly. How you mitigate that?
I won't go into detail, but yes, people have tried. And there are several mitigations on the platform side to help mitigate that. And there are always folks in the business are always evaluating the quality of data, not just the quantity that's coming in. So, yeah, you're not the first one to say that, and you won't be the last, but it's certainly a challenge for the business. Yeah.
Thank you for sharing your company's journey. It was a hell of a ride. I'm quite curious how much time / effort your team have spent on rewriting pretty much most of the code base. 30%. And so say 6 years ago, the code base was all kind of old Java stack. And then you kind of migrate to more of a latest state of the art. I'm curious how much automation are in coverage previously versus now. Yes, end-to-end coverage.
Now say that again for the camera.
So the question was, what was the automation process or the coverage like before compared to now? Before there was nothing, zero. And now we're starting to get there. We're making efforts to get there. But because we are making use of examples like the semantics modifier example that I provided with the dialogue, that gives us confidence in knowing that we're providing accessibility identifiers for all of the views that we're adding and our screens that we're rewriting. So as we want to set up automation and you're finding the views and you're clicking the views based on the text or the IDs, we have the confidence now to know that we're starting to add that. And because there's less code overall, in a way, it is easier to get to that point.
Yes.
Just curious. Thank you for the session, both of you. And have you done any performance analysis before and after the refactoring? Any performance improvements you noticed?
So one of the things about the question was about performance comparisons and if there's any improvements. One thing about Compose is because XML has been in Android from day one and is probably always going to be there, that's extremely optimized because Android's been around for a very long time. But it is very easy to be silly with your views and make them not very performant. With Compose on debug builds, you could be fooled to think this is terrible, this is really slow, because it's not optimized, because you're able to get a debug output, you're able to print and debug the tree of your composable elements. We haven't done any performance monitoring, but I do know that Google provide benchmarking libraries and baseline. I don't think it's called Jetpack. I just know it's called baseline profiles, where effectively you step through your screens and you record snapshots of what your application is doing. And that's going to give you some performance improvements because those can be shipped out with different consumers through the Play Store. So that's going to help alleviate that. But release builds are a lot faster than debug builds. They're slow because you want to be able to look at the output if you need to, for example. Any other questions?
One here.
It's probably a very basic question here, but you're saying you use 3PP libraries. So, where I work and anybody works, if you use a 3PP library, you have to, do licensing checks and vulnerability checks and all that. So if you use the Compose, then I assume all those checks that 3PP libraries that it uses, it's already checked, you don't have to worry about it, or is that something the company has to do themselves when they use Compose?
Good question. So I'd say the libraries that we would adopt or we've adopted on behalf of our clients, they supported our decisions through the process. We haven't had any issues or anything around that, any like compliance issues or anything like that. The Compose destinations is probably one of the key libraries that we would use, a third-party one, and it does seem to be quite popular, and we haven't had any issues around licensing or such. Any other questions? Okay.
Oh.
Oh.
Of course. Yes.
Thank you. That experience was valuable. I'm just curious from an operations standpoint, say when you were in the process of migrating, and how did you manage your team internally? You don't have to go into the specifics. I wonder, would you split the team into 3 targeting, just as an example? One, maybe keep the lights on, keep the service going. And the other one's kind of doing all the refactoring and testing. And a third one maybe is more kind of more for end user advocating end-to-end test user experience and all that, make sure all the accessibility is compliant, up to date, and so on and so forth.
Great question. So there's not enough engineers on the project on the mobile side to have the luxury of spreading that across. That's like, it would be amazing if we could get there, but instead, rather than having folks just own a certain aspect or domain of the application, it's just try to have everybody share that responsibility and share those learnings throughout. So it's not just this is a user experience person, this is a testing person. We all share those responsibilities because we're all ultimately contributing to the code base and the product for the client at the end of the day. Any final questions? Thank you so much, folks.
Cheers.
Thank you, guys. And those are the hoodies for you.
Oh, we have to, yes.
We have to do the obligatory.
Yes.
No, here you do this one. I do this one.
That's for you. Thank you very much.
Thank you so much. I will wear it always, even in the shower.